Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, Subject Code CS3501, Compiler Design, Unit 1, Topic Finite Automata. Finite automata are the mechanism to recognize a set of valid inputs before carrying out an action. Finite automata are a mathematical model of a system with inputs, outputs, finite number of states, and a transition from state to state on input symbol sigma. A recognizer for a language is a program that takes a string x and answers yes if x is a sentence of that language and no otherwise. We call the recognizer of the token as a finite automaton. A finite automaton can be deterministic finite automata or non-deterministic finite automata. Both deterministic and non-deterministic finite automata recognize regular sets. Non-deterministic finite automata. It is a phi tuple S sigma dou S0 F. Here S is a set of states, sigma is the symbols of the input alphabet, dou is a set of transition function, S0 is the start state, F is a set of final or accepting states. Transition table. A transition table is a good way to implement a finite state machine. One row for each state S, one column for each symbol A. Each in cell gives a state or set of states can be reached from state S on input A. Here it shows the transition diagram and transition table for the finite automata, deterministic finite automata. That means here we have the input symbols A and B. The states are 0 and 1 and 2. Start state is represented as a 0. The rounded circle is represented as a final state. Here 0 is the start state from the state S0 to S1, S1 to S2. The inputs are A and B. Here the states we have 0, 1, 2. From state 0 to state 1, what the input is traveling, you have to mention that. Likewise, each and every state, you have to mark the input. That is represented in your transition table. Deterministic finite automata. A deterministic finite automata is a special form of a non-deterministic finite automata. No state has epsilon's transition. For each symbol A and state S, there is at most one labeled edge, a leaving, that is transition function is from pair of start symbol to start state of states. Here it shows the diagram shows the deterministic finite automata for the example A, B, the whole asterisk. For that first you have to draw the transition diagram. Here the transition diagram A and B is represented as a input, the 0 is represented as a start state, the double circle is represented as a final state. So from one state to another state, what are the input traveling you have to mention in your transition table. Construction of a non-deterministic finite automata and deterministic finite automata from a regular expression. To convert a regular expression to a non-deterministic finite automata using Thompson method. Syntax directed, that means it works recursively up the pass tree of the regular expression. For each sub-expression, a non-deterministic finite automata with a single accepting state is built. The next one is finite automata, that means conversion of a non-deterministic finite automata to a deterministic finite automata. In this diagram, it shows the subset construction, that means each state of deterministic finite automata corresponding to a set of non-deterministic finite automata states. Here the states may be exponential in number of non-deterministic finite automata states. Thank you.